Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at finding the equation of a polynomial graph after looking at its transformations. So what I've done is I've taken the graph of y equals x to the power of 4 here. So it's like y equals x squared, except it's flatter down here and it gets bigger quicker. So that's the graph of y equals x to the power of 4. Let's use that to find the equation of this graph here. So as I told you in the question, I obtained this graph by just successively transforming this graph here. So we can see the turning point 0, 0 has been moved down here to -1, -3. So first, let's look if there are any dilations. Well, this graph here hasn't been stretched to get this one here. So for example, this point 0, 0 has gone to -1, -3, but you can see I go across one, down one on both sides. Here, I went across one, up one. So it hasn't made the distance that I've traveled when I go across, it hasn't made that any larger. So there has been no dilation here. What we do know, however, is there's clearly a reflection about the x-axis. But to get this point 0, 0 to -1, -3, I can't just reflect it. It also needs to be translated. So there was no dilation, remember. So what I've done is I've taken this point, I've moved it 1 to the right, and I've moved it 3 down. So that will allow me to get the yellow graph from the green graph if I reflect this about the x-axis and translate it 1 unit right and 3 units down. So then what would be the equation? So the original equation was y equals x to the power of 4. Because it's been reflected about the x-axis, what we need to do is put a negative out the front. Now, it was translated 1 unit to the right. Remember, when translating right, it sort of goes the opposite way you'd expect. We went 1 to the right, so this number in the brackets is negative. We need brackets around it. And then to go 3 down, we need to subtract 3. This would be the equation of the yellow graph based on its transformations. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.